And energy work. When a constant force F acts on a particles and the motion of the particles takes place in a straight line in the direction of the force, the work done by the force is defined as the product of the magnitude of the force and the distance x through which the particle moves. Thus the work W is equal to F into x. However, a force acting on a particles may not act in the direction in which the particles move. Here, the work done by the force is defined as the product of the component of the force along the line of the motion of particles. If theta be the angle made by F with the line of motion of the particles, then by the definition of the work, W is equal to Fx cos theta. It means W is equal to Fx cos theta. The work done by a force, यानी कि force is into displacement along the force. Work is a scalar quantity. SI unit of work is Newton meter, which is called joule. The value of work done will be maximum when the theta is equal to 0, and the value of the work done will be minimum when the theta is equal to 90 degree. It means when the max work done is equal to when the fx work done is maximum f into x, when work done is minimum when the w work done is 0. Power. The power of an agent is defined as the rate at which the work is done. The average power delivered by an agent is the total work done by the agent divided by the total time interval. Thus, power P is equal to work done by time interval. The instantaneous power of agent P is equal to dW by dt. The SI unit of power is watt. 1 watt is equal to 1 joule per second, यानी कि 1 joule Newton meter per second. The power of machine is expressed in the horsepower, and 1 horsepower is equal to 746 watt. Watt second is the unit of the work. Watt hour is also another unit of the work. 1 watt hour is equal to 360 joule. Kilowatt hour is also the unit of the energy. 1 kilowatt hour is equal to 1000 watt hour. 1000 watt into 1 hour is equal to 1000 watt into 3600 second. It means 3.6 into 10 to the power 6 watt second. It means 3.6 into 10 to the power 6 joule. Thus W kilowatt work done, watt, kilowatt, megawatt and horsepower etc are the unit of the power, while W work second, work hour and kilowatt hour etc are the unit of the work energy. If the force applied on a body is not constant, rather vary with the distance, within the total work done by the force W is equal to integral of F cos theta into dx. The work done is stretching a spring, hence the distance is equal to x is equal to 1 by 2 k x square, where x is equal to spring constant. Energy. Energy of a body is its capacity of doing work. In mechanics, general physics, a body is capable of doing under two circumstances: when it is in motion and when it is situated in the field, or it is strained. Thus, two types of energy usually coexist, one due to the motion and another due to the field of position. Kinetic energy. A body describing the motion acquire a linear velocity and developing a capacity of doing work with its kind called kinetic energy. If the m be the mass of the body having a velocity v, then the kinetic energy of the body is given Ke is equal to half mv a square. That implies half mv a square is equal to p a square by 2m. It means the relation between kinetic energy and linear momentum is kinetic energy is directly proportional to the square of the linear momentum. Thus, if the mass of the body is made double, the kinetic energy is double, will become double. While the either velocity and or linear momentum of the body is double, the kinetic energy is become 4 times the original value. Potential energy. If the body develops a capacity of doing work due to its position or field, it is called the potential energy of the body. If m be the mass of the body and h be the height or position of the body where acceleration due to gravity is operative, then the potential energy of the body Pe is equal to mgh, where g is equal to acceleration due to gravity. When a bullet strikes a target, it penetrates through the target and works against the resisting force offered by the target. This is the kinetic energy of the body, and it is measured by the work it can do in being brought to rest. When the body is kept in the field, it works due to its position in the field. This is obviously potential energy, thus the unit of the energy is obviously the same as that of the work. Conservative and non-conservative force. A force is said to be conservative if the work done by it on any particle that moves between the 2 points depends only upon these 2 points and not on the path followed. A force is non-conservative if the work done by the force on a particle that moves between 2 points depend on the path taken between those points. Thus, a force is said to be conservative if the work done by the force on a particle is round trip is zero. The force is said to be non-conservative if the work done by the force on the particle round trip is not zero. For example, gravitational force, electrostatic force, adhesive force, and cohesive force etc. are conservative force. Viscous force, frictional force, damping force etc. are non-conservative force. Law of conservation of energy. The energy may be transferred from one form to another form, but it cannot be created or destroyed. The total energy of any body or system is constant. Also, whenever any energy in any form disappear, then the same amount of energy appear in another form. This is called law of conservation of energy. Equipment and transformation energy. From the solar cell, solar energy is converted into electrical energy. From the dynamo instrument, mechanical energy is converted into electrical energy. From the electrical motor, electrical energy is converted into mechanical energy. Microphone, sound energy is converted into electrical energy. Loudspeaker, electrical energy is converted into sound energy. Musical instrument is converted into mechanical energy to sound energy. Bulb tube, electrical energy into light energy. Heater, electrical energy into thermal energy. Candle, chemical energy into light energy and thermal energy. Coal, chemical energy into thermal energy. Electrical cell, chemical energy into electrical energy. And heat engine, thermal energy, heat energy into mechanical energy. Gravitation. Gravitation is the weakest interaction or force among all the four types of interaction existing in our universe. Each and every body attracts each other by virtue of its mass. This is called gravitation. Newton's law of gravitation. In our universe, the force of interaction acting among the two bodies is directly proportional to the mass of their bodies and inversely proportional to the square of the distance of the bodies. It means if m1 and m2 be the mass of the two bodies and at a distance according to the Newton's first law, a force is directly proportional to the product of mass 1 and mass 2 and inversely proportional to the distance. Distance between the two masses square. So F is equal to g into m1 into m2 by r square. The value of g is 6.67 into 10 to the power 6.67 into 10 to the power minus 11 Newton kg square, Newton meter square per kg square. Gravity. As the Newton's law of gravitation, the force of interaction exists among the two bodies. But if in two bodies, one body in the earth, then this gravitation is called gravity. And by this force of gravity, the earth attracts every body towards its center. If a body is projected upward freely, then due to the force of gravity, it falls back. Acceleration due to gravity small g. If a body is dropped freely and it execute a free falling motion, then As the body comes near the Earth's surface, then its velocity increases and acceleration produced is called the acceleration due to gravity. If m be the mass of an object of an body describing a free falling motion, then due to the presence of the force of gravity, the weight of the body then the weight of the body if m be the mass of an object body describing a free falling motion, then due to the presence of force of gravity or the weight of the body is m into g, where g is equal to 9.8 meter per second square in the feet, 32 feet per second square. Acceleration due to gravity near the earth's surface. In SI unit, g is expressed is the meter per second square or newton per kg. Relation between universal gravitational constant and the acceleration due to gravity. If the Earth is supposed to be the homogeneous solid sphere of masses me and another body of the inertial mass m be located at the surface of the Earth, then the force of interaction of the body of mass m is equal to m g into mass of the Earth into m by radius of the Earth ka square, where radius of earth is equal to radius of earth, r is equal to radius of the earth. Now by Newton's second law of motion, force is equal to mass into acceleration. It means m into g. Now m into g is equal to uh, g into a mass of earth into m by radius of earth का square. It is equal to g is equal to m g into a mass of earth by radius of earth का square. Here we assume that the initial mass is equal to the gravitational mass. Obviously, the value of the acceleration due to gravity is 9.8 meter per second square, does not depend upon the mass of the body. Thus, two body of different masses, if air resistance is to be negligible, fall freely, then both have the same value of the g near the earth's surface. Thus shows that if two bodies of different masses, shape and size are dropped in the vacuum from the same height, then the both will reach the ground surface simultaneously in the presence of air, the viscous drag, buoyancy, etc. The motion free falling of the bodies are affected, and thus the heavy body comes down earlier than the lighter body. Variation in acceleration due to gravity at the altitude of a 45 degree and at the sea level, a standard value of 9.8 of the value of g is 9.8 meter per second square or 32 feet per second square. But the value of g is not constant and varies from the place to place due to the spheroid shape of the earth. The derived g is equal to g into mass of earth by radius of earth square, and since the equilateral diameter is larger than the and diameter pole diameter, the value of g in the equatorial region is less than that of the polar region. It means at the pole value of g is maximum, at the equator value of g is minimum. Due to the acceleration of the earth, if a body of mass m is kept of the earth's surface at any place whose altitude is lambda, then due to the earth rotation the weight of the body is observed to have changed. This change the weight of the apparent weight of the body. Obviously an apparent weight appeared due to the variation in g. In fact, the body described traces a circle of radius r is equal to radius of earth cos lambda due to the earth rotation. The expression of the apparent weight is derived as the apparent weight Wt mg dash is equal to mg minus m omega square r cos square lambda. Obviously, if the earth stops to rotate, then the omega is equal to 0. Here g dash is equal to g. If the earth rotation increases 17 times the present value, then the weight of apparent at the equator will be 0. Obviously, the value of g is increase or decrease is the value of angular velocity of the earth and vice versa. with distance from the center of the earth. Here the graphical representation of the variation of g with the distance has been displayed. The value of g is equal to 0 at the center of the earth. It increases linearly with the distance up to the surface of the earth and then decreases rapidly and again becomes 0 at infinity. The acceleration due to gravity is maximum on the surface of the earth. The variation is going up from the earth's surface and coming down from the earth's surface. First, the value of g decreases in going up. If an body goes each height from the earth's surface, then the value of g decrease and say g dash is which is g bracket 1 minus 2 h by radius of earth. The value of g is also decreases in come down if an body come down to h height from the earth's surface. The value of g decreases. We say that g dash is which is given g dash is equal to g into 1 minus h by re radius of earth. The g value of g from going up or coming down inside the earth decrease but decrease more on going up than the coming down. Application of the variation of g. If a lift or elevator goes up with an acceleration then the man sitting in it experiences a large weight that of the original. Thus, the apparent weight mg plus ma increase the weight, where ma is equal to the mass of the man. M is equal to the mass of the man. Similarly, if a lift or an elevator come down the acceleration to a, then the man sitting is experience the lesser weight than to his original weight. Thus, the apparent mg minus ma decreases weight. If a lift or elevator moves up with a constant velocity, no acceleration up or down, then there is no change in the weight of the man. If during coming downward the rope of the lift or elevator gets broken, then a free falling motion occurs and sitting man experiences the weightlessness. Since during free falling a is equal to g, thus the apparent mg is equal to ma mg, and it means mg is minus mg is equal to 0. If the value of the acceleration a of the lift or elevator during the coming downward become more than the g, then the sitting man on the floor and lift would escape the roof lift. If a is greater than 0 g, then the apparent weight mg minus ma is less than 0. It means negative. Thus, the apparent weight negative, physically active. The man upwardly and man comes on the roof of the lift elevator. Thank you.